Okay, let's look at this example. Let's notice that, I don't know why this thing's all showing up, sorry. And let's notice that we have a difference of perfect squares. So when we see the difference of perfect squares, the subtraction, that tells us that this expression is a leg on this right triangle. So when we draw our triangle, we either choose the leg to be here or sorry for being slow. I'm drawing on a tablet, as you probably know. So these are our two choices for where we place the leg. This is equivalent to saying theta can go here or theta can go here, right? So either the point is it's either adjacent to theta or opposite of theta. Okay, so I know that that's one of the legs. The other leg has to be the x because it's being subtracted from the hypotenuse squared, so the hypotenuse is 5. Now, if you're not sure if your triangle is correct, you should do Pythagorean theorem on them and make sure that it's a true statement. So notice that if I do this squared, x squared, plus the square root of 25 minus x squared, all squared. So when you square that, of course, you're just going to get 25 minus x squared. So you'd have x squared plus 25 minus x squared. The x squareds cancel and you're left with 25, which is equal to 5 squared. So the a squared plus b squared equals c squared would work. If you messed it up and thought the 5 went on the leg, for example, and the x was on the hypotenuse, then Pythagorean theorem wouldn't work. So that's always a good check, just to make sure that everything's working out correctly. Now, remember that what we want to do is now write a ratio. So we have our choice. We want to choose which one is better here. So I want to write the ratio using the two simplest sides. Oops, let's erase that. I don't want 5. I want it always to be with the x over so using the two sides with my variable on top, so x over 5. So in this picture, I look and see which ratio gives me opposite over hypotenuse. So that's going to be sine of theta. So that's a pretty good choice. Notice that over here the picture would be for cosine of theta. Again, as we talked about, that would work too, but I'm going to just go ahead and choose sine. So I'm going to erase this guy. Okay, so my substitution is that if I multiply both sides of this equation by 5, sorry, I don't know why that little pen thing is showing up. We have 5 sine of theta is equal to x, and so the derivative dx, derivative of sine is cosine d theta. Okay, so when I go to make my substitution, I want to replace everything that was in terms of x's in this integral, all to be replaced with things in terms of theta. So there's no x's in the numerator, so that just stays 1. In my denominator, instead of writing x squared, I'm going to write 5 times sine, that whole thing squared. So 5 sine theta squared. I'm going to skip over the square root for a second and then realize that dx also has to be replaced, and the dx is going to be replaced with a 5 cosine theta d theta, excuse me. Okay, I'm going back to the square root because one way to deal with this is I could rewrite the x as 5 sine theta, and I could write it as 25 minus 5 sine squared. And I could do that, and we could use a Pythagorean identity, and we could simplify it and all of that. There's so brute force would get you there. But a slightly easier way is to use the triangle. So if I look at my triangle, I'm looking for something to replace my square root of 25 minus x squared. So I want to look for a ratio that has the square root of 25 minus x squared in the numerator, and the easiest other side I could possibly use. So I'm going to use the hypotenuse in the denominator. So what is adjacent over hypotenuse? That's cosine. So if cosine, sorry for being squished, cosine is the square root of 25 minus x squared over 5, then it must be that 5 times cosine of theta is equal to the square root of 25 minus x squared. So this fact, right, so instead of writing square root of 25 minus x squared, I'm just going to write 5 cosine theta. I'll show you the other way to have gotten it just because we have the time, right? So the other way would be to just brute force 25 minus, instead of writing x squared, you'd write 5 times sine of theta, that whole quantity squared. So that's 25 minus 25 sine squared. You'd have to then factor the 25 out and be left with 1 minus sine squared. And then you have to recognize that 1 minus sine squared is the same thing as cosine squared. Then when you take the square root of each piece, you get 5 cosine theta. So you get the same result in a longer way. You guys have the ability of pausing this video and everything, so I'm going to erase it so that, because if you want it, you can just pause the video and copy it down. But I need the space for the rest of my problem. Okay, so now let's look at our integral. However you look at it, we eventually have 1 over 5 sine squared times 5 cosine, and then again times a 5 cosine. So we've got a 5 cosine in the numerator and a 5 cosine in the denominator. That makes things nice because now we can just cancel. And again, we should be expecting lots of things to be canceling when we're doing these sorts of problems. So I'm left with 1 over 25 sine squared theta d theta. Make sure you square the 5 also. That's a common mistake for students. So that's 1/25 times, if I want to write it another way, this is cosecant squared d theta. Now, if this was secant squared, I think we all would recognize the antiderivative of secant squared is tangent. And that's the kind of thing that, like on a test, I would expect you to know. So if this were secant squared, I would expect you to recognize the antiderivative. I don't expect you to recognize the antiderivative of cosecant squared, but for a homework problem or for notes or this type of exercise, I'll just tell you, or this would be something I would ask you to look up, the antiderivative of cosecant squared is negative cotangent theta. So the antiderivative of secant squared is tangent. For cosecant squared, it's negative cotangent. And so we have negative 1/25 times cotangent of theta. We have to, so all I did was bring that negative out. We have to write an expression that's equivalent to cotangent of theta, but using x's. So we go back to our triangle. Cotangent is the adjacent over the opposite, right? Adjacent over opposite. So that's going to be the square root of 25 minus x squared over x. And there we have it.